commissioned 50 journal pages on the topic of research waste. And if you know anything about the cost of producing one journal page for the Lancet, it's well over $100,000. So 55 pages is quite an investment by the journal. And that was in 2014. And more recently, there has been the MINUS framework, MINUS looking and essentially at a framework of thinking about how to reduce waste. And we've embarked on an AI adventure, and this is with Christian Cao, who's going to be presenting today. He's the founder of Otto Labs and a medical student at the University of Toronto, a brand new university that maybe none of you have heard of. But over to you, Christian.
Awesome. Thank you so much for the intro. So for today's session, I'll keep it a bit more interactive with a live demo component on top of the slides. My plan is I'll quickly jump in, actually start the demo just because there'll be like a brief loading phase, and then we can sort of bounce into the slides, go back to the demo, and then have a period just to answer questions. But to go ahead and get started, I will quickly share my screen. So as David had basically noted, one of the big components and interests of this question is that, nearly 85% of biomedical research is avoidable waste. And in lieu of addressing that, one of the ways that we were thinking is you look at a systematic review that is often treated as the gold standard in scientific evidence. What does that encompass? You're essentially identifying and synthesizing all the available evidence. Now, the issue with most of the reviews and doing these reviews is that usually it's very time consuming. The average review can take up to 2 years, cost hundreds of thousands of dollars in terms of manual research costs. But basically, we were interested because what if you could repurpose an automated systematic review tool to help immediately find out, all the studies that have already been produced on a given topic before you engage in your research. And the idea would just be, upload a research protocol and then immediately generate some sort of rapid or targeted systematic review that surfaces all the potentially relevant studies. So I'll jump into the demo. Basically, this is what the Otto browser essentially looks like. The only things that I need to get started would just be to provide basically my sort of protocol. For this example, I'll actually be reproducing or using the, Otto platform and looking at a recent review that was put out by Cochrane that was looking at all the trials on platelet-rich plasma for women with reproductive issues, or as like an IVF technique. And what we'd done is all we did was I organized things to make my life a bit easier, copying and pasting. But you can see it's the exact same language as you would put in, say, a manuscript that you're planning to prepare. But I've just organized things here to make my life a bit easier. So I can go ahead, I'll paste in the objectives. So again, we're trying to see if intrauterine and intraovarian PRP or plasma is useful for women with reproductive issues. The only inputs beyond that I would provide would be my protocol, usually in some sort of very familiar Pico format. So for example, here we have our population, here we have the interventions that we're interested in, here we have the study designs, and then the similar outcomes that we're interested in, as well as any reasons for exclusion. So here's an example of a nitty-gritty reason where we're only interested in women who actually where we want to exclude people receiving donated oocytes, distinction from autologous oocytes or self-derived oocytes, etc. And then finally, at the paper section, instead of uploading results from a database search myself, what I can do is I can automatically have an AI system create a database search, query PubMed or any other databases, and just rapidly perform a systematic review, surfacing all those relevant studies. So I'll go ahead and then create that project. So this will take anywhere from 5 to 20 minutes to load, and I'll jump back into my slides. But basically, the context of what we did is it's really just been an ongoing project. What started off as like a pure academic interest around back in May 2024, I was interested in the area of using AI to try to speed up systematic review screening. And when you decompose that task, all it is really saying is, given some article of interest, is this relevant to my research question? Yes or no? So we ended up publishing this paper in the Annals of Internal Medicine, finding that AI systems like ChatGPT can actually achieve pretty good performance for this abstract screening or article identification task. The next step of this project was actually seeing, could we tackle the next stage of data extraction? So, with that final set of articles of interest, can we also extract out, key outcome information or extract out key summary information? So this resulted in the release of our preprint. We included a lot of different sort of validation components along the way, which I'll touch on shortly after. Around January, so we actually updated our system. I also ended up launching the official sort of AutoSR website and company, and recently added support for appraisal in that systematic review process. So on top of identifying all the relevant studies, extracting out the key information, it's this added component of also assessing, what studies are actually high quality, what studies are free of methodological concerns, and applying those validated tools that we use in systematic reviews today, like ROB2 for RCTs, Robbins for observational studies, or QuadAS for diagnostic test accuracy studies. And more recently, we've now actually just added that new experimental feature where we try to actually have the AI system automatically generate a database search, automatically go through PubMed, identify a large corpus of studies to then upload into the auto system for the automated screening, data extraction, and downstream steps. Our interest is eventually seeing, how far we can push the limit and whether we can also just fully automate the systematic review process, including the analysis and report generation. So those are definitely ongoing and upcoming steps. But for today's presentation, we'll focus on mainly the first three components, namely the search, the screening, as well as the data extraction. But with that in mind, as a very quick overview of the platform, we're really adopting the same principles as your traditional systematic review workflow. Again, it's this concept of performing a very wide search, identifying all the potential studies or citations that might be potentially relevant to this topic using broad keyword filters. So for an example, in this search, one of the common keyword search words that we might use is any study that involves the word plasma in the title or abstract. You can imagine that that'll surface all the relevant studies of interest, but then also a lot of junk inside that. Right now, the traditional way that we would sort of filter through that is we'd have two human researchers, go through, screen the titles and abstracts with conflicts adjudicated by a third reviewer. We repeat that for all the full text, and then we undergo data extraction. Our principle was let's use an AI system at each step of the way, mirroring this workflow, and then see how the performance shapes up. Right now, and for this project, we have an ongoing project where we're basically aiming to validate the search strategy. So this gets into some of the nitty preliminary results that we've prepared. But basically, we gathered a large data set of about 150 systematic reviews, all different clinical domains, all different review types. And the idea is that from each review, we extracted their protocol, their database search that was generated by the authors, and then the list of included studies. And that would almost be like our validation cohort. We then developed our AI system and we wanted to compare, how did our AI system compare to that original sort of author drive review? So it's like if an author just gave me their manuscript, their protocol with just a description of what they were interested in finding, could we, with our AI system, catch all of the papers that they had caught? We actually find that we're having pretty promising performance. So in one of our training sets, this is about 35 reviews. We're finding that we're already hitting about a sensitivity about 95%, as well as 93% in our separate validation set. We have what I call our microsensitivity. So this is when we look at just the articles that the author had actually caught as part of their database search as a more fair sort of apples to apples comparison. And we actually find it goes up to about 99% or 96%. So it's quite sensitive. And then in about 19 of the 35 reviews, we were perfect in that we basically caught all of the included studies that the authors had. And then similarly in 11 of 36 in the validation set. Here's also a general sense of how big the searches are. So we mainly just queried PubMed as well as Embase databases. But you can see that when you look at the median search size, it isn't too far off from what a traditional librarian or a human search might look like. We're in the realm of just like a few thousand articles. But our added advantage is that now when you have these thousands and thousands of articles, it doesn't really take the AI system too long to subsequently screen through them. And usually we find that our search system can finish running and produce relatively high sensitivity just within a time span of anywhere from 15 to 30 minutes. So again, these are just preliminary results. We're continuing on working to optimize the performance of the system with the goal of essentially creating, the so-called perfect LLM-driven or autonomous database search system, as well as expanding support for more search databases and then trying to speed up this process. So hopefully, instead of having to wait, 15 minutes today, so we're not far off from a world where you'll just have to wait a few seconds. The next component after we produce a very sort of sensitive and wide search that captures all the potential included articles is the important step of filtering down to the final set that we actually care about. So this is actually citing results from our prior preprint where we basically took, a whole different cohort of previously published systematic reviews. We gathered a human comparison, we gathered some other software comparisons, and we wanted to see, with all those results from this database search, what is the performance of the AI system in performing abstract and title screening, as well as subsequent full text screening steps. And again, we find that our system actually achieves really high accuracy overall. So it achieves really high sensitivity with up to 96.2% sensitivity after full text screening. And that doesn't necessarily come at the expense of specificity either. We find that we have about 97% specificity, so it's only a 3% false positive rate. And this, interestingly, in our study, was actually significantly higher than our comparisons against human reviewers, which were just more prone to accidentally kicking out articles that might have been relevant or might have been included in that original review. The component after that now was actually the data extraction. So, now you can conceptually envision after we performed our wide database search, we filtered down to, from thousands and thousands of studies to maybe tens to just hundreds of the studies that actually matter or are relevant to our question. The next thing that'd be really useful is having a structured summary of the study, whether that is by getting the specific outcome information or whether that's by getting other high-level descriptive study information, like, for example, the country, the methods, the inclusion criteria, et cetera, et cetera. So for data extraction, we adopted a really similar principle. We basically collected a bunch of previously published systematic reviews that had their raw data extraction results provided. So for each individual study within that review, there was the set of extracted information. We set that as the so-called reference standard. And then we compared our AI system against a separate team of human reviewers to see how the extraction accuracy would shape up. You can see that we actually find that we have the best extraction accuracy in class. We outperform human reviewers in basically making fewer mistakes. And oftentimes, when there were discrepancies between the human and the actual AI extracted value, when we had individuals actually perform blinded adjudication, so you had to choose between the value that you thought was correct. And we often find that folks will actually side with our AI system instead of the original human result. So that was the very quick sort of overview of the slideshow. I'm also just sharing some of the other core members of our team, including David, who has kindly been providing sort of research advice throughout. But that is the very quick presentation. I'll jump back into this slide, but happy to answer any questions while the auto system is just loading through.
Unmute. Thank you very much, Christian. And I see that Azadeh has shared in the chat a survey, but before completing that, you might want to wait for the results from what the AI tool is going to produce. I think I will just sort of make one comment on the bigger issue of why would you want to use this tool? Because you might want to use, because if you're applying to, for example, CHR to do a new clinical trial or a new study on any topic or a new systematic review, basically CIHR are asking you what evidence is there out there that this is unique and hasn't been done before. And so this tool, we believe, will most immediately be able to tell you that, and that this is something you could describe and cite in a CHR grant application or grant application to any other um, funder. Um, so for example, if you're sort of cardiologists or in terms of the brain heart connectum, or you're a psychiatrist or psychologist, if you're interested in doing a particular study, you could look and see, has it been done before? Has it been done in the same population? Or is there something unique that you can do here that would make the rationale for your review much stronger? So if there are any questions while we are waiting for Otto, please feel free to ask Christian or any of us. Okay, so there are no questions. So
I'll ask one if that's okay.
yeah, of
I was just
course.
curious of the limitations that you kind of foresee. Obviously, this is your first crack, so to speak, with the LMM for at this level. So, like, what do you see as limitations in what you've done so far? What needs to grow for it to be better?
Yeah, I think one of the limitations with the search component is we've automatically hooked up with PubMed and all of the different open access providers. So like OpenAlex, some of the semantic scholar searches, but we're unable to automatically query Embase without a researcher basically providing institutional access. So we're still working on exploring like an official partnership with Elsevier. Hopefully that would give us programmatic access and ultimately just expand the availability of that database search. So right now, the system, yeah, is basically just like the limitation of being able to just query open access articles. However, we do have the ability that if a researcher, does have subscription access to these databases, they're able to run the search themselves and then upload it to the platform. That is something that we can handle. It's just the automatic programmatic component that's almost we're at the mercy of the publishers to address.
I I would also just say, and Andrew, I'll give some positives that this is you can use publications from any language, as of the best as I understand. And that to me is something quite positive. Not necessarily that you would include other languages in looking to see where there's waste, but at least you be able to say, ah, when we looked at all languages, we identified nothing. Let's supposing you're looking at acupuncture. Um, um, we identified nothing in the Chinese literature as one example. I think that is a really big positive that often people don't do or can't do. And I think the other big positive, I know you asked about the limitations, but I think the other big positive is that in general, you can do this in under 30 minutes. Not simply the search, but you can actually identify in under 30 minutes whether what you're proposing is something unique or not, or whether it's been done 10 times before. Osmo, I see your hand is up.
Yeah, I have a question. When you search these databases, are you just searching abstracts or articles and diagrams and tables, and is it the entire article or just parts of the article?
Yeah, so the initial database search is basically just keyword based, using the title and abstract content of whatever is available on PubMed or an open access database. So usually, and how we built our system is we built it to be very, very overly sensitive, right? So you'll see, it should wrap up in the next few minutes or so. we're actually very, very broad with the terms that we're using. It's basically any study that mentions plasma. It should mention, any study mentioning reproduction or some of these birth outcomes. All those different studies would be included. So you can imagine it's like casting a very, very almost overly wide net. The next step after that, when we actually load into the project, that's where we undergo the more traditional systematic review process, adopt elements in a two-stage fashion. So first off, you have your traditional abstract screening, which is also quite sensitive in that it's just basically including different abstracts based on the title and abstract content. But after that, we're then able to do a much more high accuracy full text screen. At that stage, that's where we'd actually use the entire full text content. So all the articles, all the methods, all the results and discussion, all the supplementary information, if we're able to automatically retrieve that, all of that would just weighed into the decision. So like David mentioned, in the collective span of about 20 to 25 minutes, you would get the final list of studies with a nicely extracted sort of data table that you can then interact with and continue to work with to basically identify all the different studies around my research topic of interest.
And so, it's probably, we can certainly send you some papers following this presentation, but research waste is very real. And there is a very nice paper recently published in the Journal of Clinical Epidemiology, sort of indicating very recent examples of waste. And by waste, I mean multiple studies on the same topic and the same population. And while we may all argue for the importance of having perhaps 2 or 3 studies done that would verify or validate the results, we probably don't want 10 studies done on the same topic at the same population, the same intervention, etc. So this is a tool that will really help people. At least we believe it will really help people. And what we really want people to do is to try it out. And that's why when Otto wakes up again, if people would do the survey at the end that Azadeh has shared the link with, then I think it'll be very helpful for us to see whether others are interested in exploring and using it.
Awesome. Yes. The idea and inspiration between things right now is like as a researcher, you would upload your protocol, also be able to upload multiple queries. So we could also fire off like another separate research question. Say if I, was preparing multiple different CIHR submissions, but during this time frame, you just go up to go grab a coffee or something, and it's by the time that you come back, you've loaded into the project and you can continue onwards with things.
So, David, I have a question relates to what you just said about seeing the need to have human replication of these studies. You can see the validity of having 3 or 4 people looking at the same problem. How would you see this AI approach fitting in with that human-based replication?
So I think, thank you, Christopher. So I just wanted to make sure I understood. So you're sort of saying that you may want, let's say, 3 studies, very similar studies, all done, and they may sort of verify or validate the intervention on a particular, right?
Yes.
So I think, I mean, many years ago, I wrote an editorial in The Lancet with a colleague about unnecessary duplication versus duplication. So I think that I think in a sense, the number is in the eye of the beholder. Maybe you and I would agree that maybe 3 or 4 is useful, and we probably would agree that actually 7 or 8 are not useful. but we see many examples of, I was working with a bunch of colleagues last year, looking at um, general medical care for diabetic patients. And there was something like 23 systematic reviews on exactly the same thing, and like almost 30 or 40 trials. That is probably unnecessarily wasteful and unnecessary duplication. Now, I'm really just want to point out that that is for the same question, the same population. Obviously, if you're looking at, let's say, something a cardiac with, um, 45-year-olds, and you want to look at that same cardiac intervention with the elderly, that's not duplication. That could be something very meaningful to do. And we just hope that this tool, people would use this tool and would quickly get an answer on whether it's in, yes, there's tons of this being doing, or it doesn't appear to be very much of this. I think that adds to the reduction of waste, and I think it adds to the stronger rationale for the uniqueness of why you may be looking for funding.
Thank you.
So, while this is loading, I'll quickly just jump in and then we can contextualize and we'll jump back to this project. But here was an earlier run, just as things are loading up. Basically, the concept is you'd load into the platform, you'd be able to actually review and see that original search. So to go back to Osmo's earlier question, basically this was the search that would be uploaded into PubMed. So you can see it's a very broad search, is looking for any concepts related to platelet-rich plasma, or in general plasma, as well as those sort of fertility or reproductive related outcomes. We get a broad search of about 800 or so papers. After that, we're able to use our AI system to automatically screen through all 800 titles and abstracts. If we wanted to double check things, it's very easy to actually see the reason why each article was included or excluded. I, as a researcher, could also spend time reviewing or providing a second vote if I didn't fully trust the system. After that, we run through the autonomous full text screening. So we go from about 800 articles down to 48 full text. What we do is we will automatically grab all the open access articles that exist in the world. And then for any articles that are behind a paywall, I can actually provide my institutional login. In my case, I was affiliated with the U of T, but for folks from the University of Ottawa, you can provide your University of Ottawa easy proxy, log in, and then automatically retrieve the articles that University of Ottawa subscribes to. After that step, and I think this is the most exciting step, we basically have the ability to go straight into data extraction. So the idea is that what we're looking at here, all 18 of these studies met that original protocol question that I listed out of basically, I want to look at all the different trials that are looking at PRP to enhance reproductive outcomes. All of these different 18 studies, we believe, are actually relevant to that question. And then from here on, our AI system will actually automatically generate all of the different, or generate a set of data extraction variables that we think might be of interest to the researcher just based on the protocol. The idea, though, is that this is just an early starting template. So I can go ahead and delete all these fields, and I can also add as many fields as I would like. And I think that the most fun part about this is we can try to conceptually think like as if we were a researcher answering this question. So off the get-go, you can see I've extracted something like country information. It's really easy for me to just go through and also even filter by all the different countries that are being reported. So looking at this very top level, you can see that there were 14 citations from Iran, but then there was only one study that was actually done in the United States. So I think there could be a potential justification that, hey, there aren't many trials that are being done in North America. Maybe there is a need for us to do a trial within Canada and see if these positive results are extending to the Canadian population. The other great thing about the capabilities for data extraction is really we've tried to design the system to be as flexible as possible. So on one hand, you can extract out specific outcome information as if you were going to prepare the data for some sort of in-depth analysis and then very easily audit that information, right? So by clicking this little icon here, I can actually see where did this AI system get that information. We can extract from tables, we can extract from figures, be very precise. But how I also like to use the system is to ask questions. So maybe an interesting question, because we're asking or thinking about the topic of fertility, is has anyone looked at age-related differences, right? Whether this intervention works better in older versus younger women. So I could easily add, age-based analysis or something as a title. Does the study look at differences between older and younger patients? And then I can even set this as a binary variable. So yes, no, and then immediately see, what is the evidence based on the past studies? Is this a potentially unanswered or unresolved area? Another thing that I could potentially think about is beyond asking questions, I could also ask for, provide a one-line statement about the efficacy of the PRP intervention. And I can set this as a free text variable, similarly save this. Once extraction is done, I can rerun the extraction. It becomes very easy for me to just basically rapidly iterate, add additional variables that just help me understand the data and help me refine my question and ultimately, hopefully, reduce research waste. Because, for example, had I been a researcher in Iran, maybe I'd be less incentivized to reperform, spend millions and millions of dollars in grant funding to redo this trial given that there's already been a wealth of information conducted from these different countries. So just rerunning things, just so we can also see the sort of summary statement. But the idea is that by incorporating the concept of the systematic review, which is fundamentally at the end of the day, just to identify all the relevant studies, extract information from them, and then analyze them cohesively, we're able to potentially reduce research waste by creating this rapid tool that can hopefully automate all those different steps, get the research users straight to this sort of end state that they can then interact with to rapidly get a sense of the literature. So jumping back here, I'm also able to, for example, filter by that age-based analysis so I can see as the results are streaming in. There doesn't seem to be any study that's been published that has done this specific age subgroup analysis. Beyond that, instead of me having to go through, pull up and open and read 18 different papers, I have a nice sort of one-line summary of what outcomes platelet-rich plasma was able to support or impact. If I ever question the results or the descriptions, it's very easy for me to go back and double check where this information was coming from. Really, for us, we pride ourselves on the accuracy and reliability of the system. And then finally, it's really easy for me to export the results as CSV should I want to, prepare this into a data table as part of my grant submission or any downstream analysis work.
Thanks very much, Christian, for that. And I think we're still waiting to see whether. So is this what you were waiting on the results for, Christian? Or
no, this is me jumping to another project just to
Okay.
contextualize, just so
Okay.
we wouldn't, but still loading up, should be done in
Right.
the next few minutes or so.
Okay. So any additional questions that people would like to ask? And I would just preface it by saying what we're interested in is whether BHI investigators would use this tool in a sense to pilot it and to see whether it, in their view, is helpful for what they do, whether they see any advantages of it or any disadvantages of it. And as I've said, before we leave today, if people would complete as a day's the link to the survey, that would be very helpful for us. And if you know of colleagues who weren't here for whatever reason and you think they might be interested in, if you'd let us know, we can share the recording and follow up with them.
I have another question for Christian. Um, we all hear a lot nowadays about LLM hallucinations, specifically hallucination of references. How are you ensuring that that there is not hallucination of clinical studies that are then being summarized?
Yeah, so I think that's the beauty of the system that we built is this isn't just using an LLM to automatically write the entire report, right? I think that that's the most susceptible component, and that's also related to this flood of just really poor and potentially fraudulent research, where you're having an LLM, generate a whole manuscript, check the references, and it's hallucinated something that looks realistic, but it just doesn't exist. And it's related to how we only apply AI to very specific tasks within the workflow. So this initial step of actually searching through PubMed, we're only looking and collecting citations that actually exist within PubMed. So there's no actual real concern of hallucinating a citation, right? When the AI system is being applied to those screening tasks and those extraction tasks, it's only being tasked the role of, making this decision on should this article be included or excluded, or extracting out this very specific data point, respectively. So those are ways where basically we apply AI to assist in the workflow, but we don't leave it in the steering wheel, so to speak, in actually generating the final report and running the risk of these false citations. Another cool thing, this should actually wrap up in about 2 minutes or so. There's a small, internally retried just as it ran into a small issue, but usually we anticipate it takes anywhere from 20 to 30 minutes. But another cool thing I'll try to show off is we also automatically integrate with Retraction Watch. So if any of these articles are retracted, that retraction status is also shown. So should, one of the citations within PubMed, I'm sure there are, thousands and thousands that might actually be unreliable or potentially fraudulent that have been incorrectly indexed. If those are caught over time, that will actually be live and updated. And we'll be able to see that that was actually an unreliable citation and factor that in when we're looking at the results on that data table.
I just
Thanks.
want to add, Christopher. I've been working with Azadeh on a particular review, and what I really love about Otto, well, there's many things, but this one I think addresses your issue. With a click, you actually get to see the article. You don't have to see, well, is that a real or is that hallucinated? You actually get the paper. And I think that is hugely comforting, at least to someone like me. This is a real paper. But, even with hallucinations, the scholarly publication community is faced with dealing with retractions, paper mills, all sorts of potential problematic things. And so it might be very interesting, let's say, in this case, where we saw, and this is completely hypothetical, but where we saw 14 of those papers were from Iran. If we were doing a grant application and we said, oh, by the way, of these 14, we know that 7 of them or 10 of them were published in predatory journals. That's a problem. That would be very useful in terms of a rationale. So this tool, I think, is very useful at being able to help for that. But when I was doing this review with Azadeh, when I saw the paper, I was very comforted.
I was going to ask if there is any automated screening for predatory journals.
Yeah, there isn't, we indirectly do it by just flagging the retracted status. So anything that is flagged in Retraction Watch, we're looking into, because honestly, I think this is a very new consideration within the field. Like even looking at the Cochrane Handbook on how you do the ideal systematic review, they haven't actually incorporated this formal assessment of the integrity of the underlying article, right? It's this new consideration that people are just beginning to incorporate in their day-to-day workflows. So we've been looking into other more programmatic ways into how we can also just judge the integrity of, or the potential integrity of an article. One of the big advances is that all of a sudden there's a lot of these research risk indexes, both looking at like the author institution, the author's own history of retracted articles, etc. So those are also ongoing things. But at default, it's just this integration with Retraction Watch so that if any article is retracted, we're able to flag that status.
I mean, I think downstream, it's probably very easy. Here's me saying easy, and I'm no techno. But what would be a huge marker would be for Otto to be able to go and say, here's the journal type, and cross-index it with DOAJ, the Directory of Open Access Journals, because predatory publication is only affected by OA. So it's not an issue, for example, with the New England Journal of Medicine. It's only an issue with online. So it could be that Otto could cross-reference the journal against DOAJ. And if they don't match up, that could be another marker or a marker that many people would accept. Oh, this is a problem if it's not in DOAJ.
Awesome. So apologies for the wait, everybody. A bit longer than usual, but we've just loaded in. So we can similarly, just as I'd shown earlier, actually see what was the generated search for that project, what was being sent over to PubMed, and then automatically pulled into the Otto system. So these are all the different abstracts. As David was explaining, I just quickly fired off abstract screening. So right now, for all 3,000 abstracts, these are undergoing screening by the AI system. And to address, Christopher, your earlier point and what David was referring to is if I click the different record, I can see that exact citation, whatever was actually indexed in that original pub. So we sort of leave it up to PubMed in that this is actually a component where it is an AI generating the citation. It's whatever was actually indexed in that database. And then you'll see abstract screening should wrap up the next few minutes or so. We can run the full text screening. I'll retrieve some additional open access articles. We can run into the data extraction and then similarly apply any additional sort of variables, filters, or anything that might be of interest to us.
And then, Christopher, just if you look on the right part of the screen where you say info abstract, you can also, when it's available, you can look at the full text. So you can, in a sense, see what the AI has done. So in this particular case, it's not there, but I've seen them on many, many occasions. So it's very good to have.
Yeah, so in this case, we just loaded the abstract screening. You can see that we're just automatically grabbing some of the open access articles that exist out there. If I wanted to, I could also provide my institutional access and try to retrieve articles as well. Otherwise, for any missing articles, it's super easy to drag and drop. We also have ability to bulk upload PDFs. But our goal is just to try to keep everything as programmatic so that for the researcher, once you load in, all you're doing is just clicking through some buttons, kicking off the screening process. With full text screening, we also have the ability for people to get even more specific. So this is where you could get into the really nitty gritty of like, there must be this specific method requirement, or just get into details that usually aren't reported at that title or abstract level. And just providing that optional level for additional granularity. It's not something that in our testing is ever actually needed either. Really, the goal with the entire system was just build something that's really simple and intuitive to use. So for most researchers with the goal of reducing research waste, our vision is just take whatever you're preparing for your grant submission or whatever protocol has already been drafted up, input that into Otto, and then we'll handle the rest with getting you at least a rapid or targeted systematic review that we believe has excellent coverage of all the articles that are potentially relevant, at least within the open access databases.
Yeah. And I would say I would argue in many cases for looking at waste, you don't need the full protocol. I think if you're using the framework of PCOS, you have the critical information, the participants, the intervention, the comparator, and the outcome. if you have that information, that alone is going to be able to tell you whether what you're proposing has been done on several occasions or not. And I think that is undoubtedly really important information for a grant application. At the same time, it will hopefully help reduce research waste. And there's many ways that we can look at research waste downstream.
Awesome. So yeah, in this instance, we also finished full text screening. Just to progress along, I jumped over to data extraction, fired off extract data. So this is extracting all the information that the AI system initially just generated as a starting template. But if anyone from the audience has like any ideas for additional variables that we wanted to add, can very quickly add it in, rerun the extraction, then look through the results. And then from here, super easy to export the results as CSV. And basically go back to the project as well. So it's like if I do have, my maybe envisioning a sort of workflow is, for our question, we realized that there is already a lot of other research topics that have appropriately addressed it. Maybe I test out a completely different topic, or I want to have like a more specific tweak. We also have this ability just to rapidly iterate. So if I wanted to go back, tweak my protocol and rerun the screening, it's very easy to do so. And that's what we think is actually the biggest unlock with AI is once you can achieve very reliable performance, it now unlocks new ability for researchers to test out different ideas. The other great thing that I like is, again, that concept of also just firing off multiple things in parallel. I didn't show off that concept, but it's very easy for me to basically create multiple projects within Otto and then go on my coffee break and come back to, like 5 completed different sets that I can then review. But yeah, happy to answer any other questions that might have popped up, as well as just show off some of the, I guess, like validation features that we've tried to add to also enhance that sort of the ability for researchers to verify things, as well as the transparency of the system.
Many thanks, Christian. And hopefully you've all had an opportunity to complete the very brief survey. And then please feel free, thank you very much, Christopher. Please feel free to reach out to us if you would like more information, or a colleague who might be interested in piloting this. We need people to use it. That's how we're going to get better at it, and in the real world. So for the BHI, that may be hopefully something you'd be willing to do. Okay. I think if there's no additional questions, I don't want to keep anybody because I know everybody's busy. But thanks for folks taking the time to come and listen and see. I hope I hope that it excites you to pilot this with us. And thank you, Christian, for taking the time to do the demonstration and talk. Is very much appreciated. And everybody else, thanks for your questions, and have yourselves a good rest of the day. So thank you again.
Thank you.
Thank you.
Awesome.
Bye-bye.
Thanks everyone for joining.